Hello Internet! Today we are going to be making a way to render a graph in Unity. I need a way to be able to render a 3D graph that has both nodes and edges and has a weight to them. We're not going to actually, in this video, we're not going to use it for anything, we're not going to do anything. I just need it to render for some other projects that I'm working on. So that's what we're going to do here, try to get a Gizmo set up that can be given a graph and then actually figure out what to do with it. So there's actually a lot to this, which is both good and bad, I guess. The annoying part is there's two ways to make a graph. You can have like an edge list and a node list, and kind of figure out what points to what, or you can have a matrix that defines every node is on one side and every node is on the other side, and then just kind of check a bunch of boxes, and every box that is checked represents a connection between the two. I don't know I don't know what it makes the most sense. For the most part, I tend to lean towards the first option because the matrix seems like it's nicer to read, like, for me, but it doesn't seem like it's nice to actually like conceptualize and talk about. So I think we'll lean towards that one. This is going to be hopefully pretty scrappy and pretty quick because it's just a debugging thing. This is just so we can get some visuals working so that hopefully I can show you and me what's actually going on when we make these things. Because I don't actually know. So that's what we're going to try to do here. So I'm just going to throw together a graph object. And the idea here is this is going to store the three types. So we're going to have our graph, we're going to have our node, and we're going to have our edge. I should probably make those go away. Our edge and our node. And those are the three basic types that we're going to be working with. My editor is totally screwed up because I was working on something else. So the graph is just going to store a public list of nodes. We'll just call this the nodes. And so you can get and private set. Sure, I think this makes sense. And a public list of edges. And you can get that and private set it. So these setters are private because I don't want you to completely erase, like plug in a full new list of edges. That isn't the goal. I want you to be able to add to this, but not like totally destroy it, because that way we can actually reference the list in other things, and it will never go away because we have control over that. If we give control away, we can't count on these references not changing. Which means if for whatever reason we're doing something that needs that to be constant, that would prevent us from assuring that. So let's just make a really quick constructor then for our graph. That's going to initialize both the nodes and the edges, because they can only be set here. So we actually need to initialize these to something, because otherwise they'll just be null forever. So new list of nodes, and the edges will be a new list of edges. And that's our graph. Like, trying to keep this as simple as possible, and we can start adding to this as we need it, but that's it. And then the node is going to have a color, and that's it. So public node color. So you can get that and you can set it so we can change the color, but we can also get it to render it so that something else can actually be given a graph and then iterate over all the nodes and figure out where to draw them. I'm also going to give it a vector 3. I'm stuck on one thing. I can make these generic, so I can give this a t node value and like a t edge value, and then we can configure the value that our node stores and the value our edge stores generically. So we can just kind of plug that in as a use case, sort of like we're doing with the list up here. I don't know. Sure, it shouldn't be too much harder. Like, that should be all that we need to do here. And so this will just be the value. And I don't know how much we're going to use that for right now. What I'm picturing is the node is going to have a position. So I was going to plug in a vector 3 here of like the position of the node, but that actually kind of limits the idea of our graph if we force it to represent like 3D positional space. There's other things that we could represent with a graph, like a relationship of entities or like a technology tree or something like that. And so just having it use positions doesn't make sense. For our use case, in this case, it does. But adding this generic value seems like it should be a good choice. And so I'm going to change this graph then to be a graph of T node type and T edge type. And so our node is going to be of type T node type, and this is going to be edge of type T edge type. Why doesn't it like that? Oh, because we haven't changed this. So T node type and T edge type. Edge cannot be used with the type arguments because we haven't given them, so T edge value. I should change these so they match, because otherwise I'm going to get confused and you're going to get confused, or I know I'll get confused, and that's really what matters here. And then our public edge is going to actually have the same thing. It's going to have the color and the value. And because we're using generics here, the values aren't necessarily the same between a node and an edge. So an edge may have a weight or a list of requirements in order to unlock that specific edge, or whatever else you want it to have. That's sort of the power of these generic types. And hopefully, hopefully we can do that. Let's change this to the edge color. So we have our color and our value for both of these, and that should be everything. We're just going to expose these lists, which means you can actually run like a clear on them. You can remove nodes and you can add nodes, and we don't have any hooks. One of the downsides of doing it this way is there is no way for our graph to react when we add new nodes or new edges. So if we wanted to like do something like that, this approach won't work. But for scrappy stuff, should be fine. And that's sort of what we're doing. I would change this design if I was intending to take it further than that, though. I should say that because I don't want you to take this and then wonder why it's so hard to actually get this to do what you want it to do. Change this design is effectively the best advice that I can say. So let's do a graph component. And so this is just going to store a graph, I guess. And honestly, so I was going to do something different to draw Gizmo, so have a second bit to draw the Gizmo. I'm going to do it on here. I think that just makes sense. And we can split it up. One of the advantages of just being able to refactor things is you can just cut things in half and move them wherever. So I think it makes more sense to do it all here, and then we can work with it there. So let's create a private graph like so. And we're actually going to need to initialize this because it's just a graph. Unity's not going to have any idea what this is. It's not going to be able to save it or do anything with it. So everything we do has to kind of initialize it ourselves, which isn't great, but that's the way we have to do it. We could fix it, but we're not going to. So we've got our graph. Oh, requires two types. We'll do a vector 3 and a float. So I'm just going with positions and then weights. That's sort of the general thing. So like pathfinding kind of stuff. And so from there, we should be able to just initialize our graph. So our graph equals a new graph, like so. That will set both the lists. It will call this constructor, set them both to have no edges and no nodes. And so now we just need to actually add some nodes. So var node 1, var node 2, and var edge 1. Not the cleanest way to write this, but yeah, we're gonna go with it. And so we'll create a new node for a vector 3. And I want a constructor on here, so I can just do give it a value here. And so we should be able to do that. We could cheat. Do I want to cheat? So there's a way to cheat by doing like value equals. This works for properties to my knowledge. I don't think it works for fields, but you can just do like vector3.0. And that will construct the object and then immediately set the value of the object to have whatever you say. So in this case, I'm setting the value of it to be a vector3.0. And that avoids having to create a constructor, and it means that we can actually kind of dynamically construct these things. So if I wanted to also give it a color, what was it, node color equals color dot red, I guess. That works too. And so you can just kind of keep adding to this and taking things off and doing whatever. So that's handy. I guess we can just keep that and create another one. And this will be our, let's see, red. We'll do green. Let's not do green. Let's do like a blue or cyan, just so it's a little bit easier to see. And we'll do a vector3.1. So that's going to need to be a vector 3 where every component, the x, y, and z, are all equal to 1. And so we should get a positive diagonal thing going when we create this edge, which is going to be a new new edge. This isn't going to work. I haven't constructed my edges correctly, because we are going to set the value equal to 1, just so it has like a default value of like 1.0. And then we need to come here and realize that our edge doesn't go from anywhere to anywhere. So we need 2 extra types here, which means I might need to inject the type of edge I'm using here as well. So we'll do a node of t node type. Sure, and that'll just be from, and another one of t node type 2. So our vector is going to go from one node to another node, and that's pretty much it. We don't have this generic type though. One of the disadvantages of using generics is we actually need to know what things are. And so I'm going to just inject it there. We can change this, especially since this is like my code, and I'm not shipping this anywhere. It makes some sense to kind of hack this together, and then as we start using it more, figure out what we're using it for, and refine where these types go, what goes first, what matters more, and whether we should do some nesting or anything else. For now, this should be fine. So we'll do that, and we'll say this is a node of vector 3s. And this, yeah, we do have it taking in nodes. And so I can say it's from node 1 to node 2. And so that should create our graph. And yeah, should be everything we need, I hope. And so the final thing we need is some way to draw gizmos. So void OnDrawGizmos, like so. And the first thing I'm going to do is say if, not do anything with my iPhone, if a graph is equal to null. So if our graph hasn't been initialized for whatever reason, we're going to call start. One with the editor, start gets called the first update. There's no updates in your editor, and so we want to make sure start gets called, and that's one way to do it. So it shouldn't actually matter. We could actually just call start every single frame, because this is like a hermetic thing. It's not going to actually change what happens every time you call it, or create anything, or do anything like that. It's just recreating a graph every single frame. And so it wouldn't be that big of a deal, but we can just do this check, and if we add those things later, like we start creating game objects in here, then we don't run into those problems. So that's what we're going to do. And then the next thing, I think we want to draw our nodes, and then we'll just do our edges, and I think that's it. Like, from what I'm assuming, I could be wrong, but for what I'm assuming, this should be really easy. And I have screwed easy things up before, so let's see how this goes. For every node in our graph nodes, we are going to set the gizmos color equal to the node's node color. And then we're going to draw something. Let's do a draw sphere at the node's value with a radius of like 0.125. So an eighth of a meter. Make that a float so it actually likes that. And make this a for each so it isn't breaking. And that should draw our nodes. So hopefully I haven't screwed that up. And we should be able to repeat this for our edges. It's a little bit more difficult because we actually need to look up the nodes that we're actually referring to. But that's not too big of a deal. So edge, and we'll take the edge color. And then instead of drawing a sphere, because it's an edge, we want to actually draw some sort of ray or some sort of line. So we'll do a gizmos.drawLine from edge from dot value to the edge from to dot value. And so that's just going to draw a line from one point to another point. And so in this case, we should see two circles, one red and one cyan, and we should see one edge. I haven't given it a color, so let's do that. I'm going to fix the formatting a little bit so that we don't get weird things, but we'll do a edge color, and we'll set this equal to color dot per fuchsia. Is it yellow? We'll do yellow. Because that's a color that I know exists in Unity's color thing. And so that should hopefully draw a yellow line between a red and a cyan circle. And hopefully, if I start this, we'll need to create a new empty game object. It did not like this. What did I do? Oh, we need to give it the node type. Node type, and I did it everywhere else, so that should cover everything. Should get rid of these two compile errors like so. And now we have this game object. Let's just drop our graph component on it. That was anticlimactic. Why wouldn't that have worked? We have no console errors. Did I spell OnDrawGizmos? Debug.log. Drawing your gizmos. The only thing I can think of is our graph is initialized and it's actually saved to this private graph. So that should be fine. But what I'm thinking is maybe our graph doesn't have any nodes or values. Oh, it doesn't. Oh, duh. We need to actually add these nodes and edges into our graph. That it obviously isn't going to work quite like it is. So let's do that. And do node 1, and can I do, no, okay, fine. Node 2, and we will add our edge 1, and do edges.add, edge 1, cool. This should actually work now, instead of whatever I thought was going to happen previously. Oh, I have lied again. What have I done? Oh, okay. Unity 2019. I'm using Unity 2019, and I was confused by their UI. When it's highlighted like that, it means that it's on. So now that it's darker, in the dark theme, I guess, it means that it's not selected, disabled. This is on. Okay, that makes some sense. I should probably know how to use the tools, but I'm pretty new to Unity 2019. I got it and have done this in it, and a few other things that haven't really worked either. So there we go. We have a graph. It works. And we can draw things, and we should be able to just like add things pretty easily. So I can add like a node 3, and even though it doesn't have any edges, for example, it should show up, and we should get another cyan. That's not going to work because it's in the same spot. Minus vector 3.1, so it should appear down somewhere there, and so. This way we can actually draw a graph of 3D components that are linked by something with some values and some arbitrary data. And we can kind of determine what that is as we go. And so hopefully for like visualizing 3D relationships of things, this will come in a lot of handy because we can use the colors to represent certain things. And we could theoretically turn those colors into some sort of function of the value of the object. I haven't done that here because that's just extra work, and really that can happen in any point. But this is sort of what I wanted because it's sort of required for a few of the other projects that I want to do here. So yeah, that's where we'll leave this. Little bit bumpy in places, but I think we got there, and hopefully this is useful. I think being able to see like the relationships of graphs and things like that seems like a really useful and handy thing to be able to do, and I don't know of any other way to do it than making this stuff, and it's not too hard. We did it in 20 minutes. So yeah, that's it for this video. So until next time, see you internet.